So health checks are a bit more complicated than everyone thinks. And there's a real difference between shallow and deep health checks, and getting it wrong can actually crash your application beyond recovery sometimes. This is why it's very important to understand this properly. My goal for this video is, though, to explain you everything you need to know about health checks, different types of health checks, as you're gonna see here, best practices, and I'm also gonna show you the code so that you know how it's done in practice. And we're gonna start with an interesting scenario where our load balancer is hitting 3 different services, as you might expect. And obviously we have this health Z endpoint. And the reason it's called Z at the end, not just health, is because originally this is coming from Kubernetes. Kubernetes used to be a Google project, and within Google, they have the health endpoint. There was a collision, so they decided to add Z at the end of every endpoint, not to collide with the original intention. Now, if your application is running smoothly, you're going to return 200 for a health check, right? And if it's broken, you're going to return 500. Now, these applications, 3 services, are bound to some kind of a database in the backend, right? Now, let's say there's some kind of a network issue when connecting to the database. Or let's say the database is slow, right? And the database is returning an error, or there's a timeout. Every time this happens, the health check is going to return 500 if the health check is checking whether the connection to the database can be established or not. And once you do that, you're going to have at some point 0 healthy targets, because all of these microservices are returning an error when trying to connect to the database. And this is very crucial to understand, because at some point your users are not going to be able to use any of these services that are actually available. So these services are kind of healthy when you think about it. It's just that there's an error when interacting with the database, okay? This is why it's so crucial to make a difference between different types of health checks. And we're gonna start with the very first one, which is the liveness probe, okay? So forget about the health Z endpoint. This is kind of a bad practice. Instead, you should define 2 different types of health checks instead, or maybe 3 different types, and we're gonna talk about it. So the liveness probes usually say, am I broken beyond recovery? Like in this case, we are not, right? Our pod or our container is still functioning, even though when interacting with the database, we're gonna get an error. So instead, what we're gonna do, of course, talking to the database is gonna return an error, but what else can we do? But if there's a failure, for some reason, our application, our server is malfunctioning, then obviously we're gonna have to restart. Either the orchestrator, let's say if you're in a Kubernetes cluster, then the scheduler is gonna restart, or maybe a human being, if you're not using Kubernetes, should restart the service. The second type of a health check is called readiness probe. And the difference is in the fact that readiness asks, should I get traffic right now? So let's say this service is already up and running, right? But can I handle any requests? Should I get any traffic? Because if the service is up, but the connection to the database, or let's say to a cache, is not established yet, obviously I'm going to return errors, and I don't want that. So I'm going to say, if there's a failure, simply pull me out of the load balancer, right? I'm still alive, just don't send any requests to me, but also don't restart. Like, I'm healthy, don't restart me. I'm just waiting to be connected to the database, okay? Also, there's another one, but this is really not commonly used in the wild. Although if you look at the documentation of Kubernetes, you're going to see all 3. So startup probe, liveness probe, and readiness probe. And startup probe basically verifies whether the applications within a container is started. So this is very specific to the startup or initialization of the framework of the server. And we're going to say, or we're going to check, is our service or web service has actually started or not? Because really depending on the framework that you're using, if you're using Express on Node.js, maybe you're going to start much faster, like 3 seconds. If you're using something like Spring Boot, it can be a bit more, like 7 or 8 seconds, okay? By the way, guys, if you're getting any value from this video so far, I would really appreciate, please do me a favor and give this video a like. This is the biggest thing you can do in order to support my channel. I will be really happy to see your comments as well. And of course, please don't forget to subscribe. I'm trying to put very interesting topics recently, and this is going to motivate me to do more. Now let's take a look at the code. And I'm using Express on Node.js, but you can use whatever you want. So if I scroll down a bit, we're going to see the liveness probe. So it's very cheap. we're simply gonna send 200 back, because if we're up and running, we can send something. If we're not, obviously we're gonna send 500. For ready Z, so for readiness probe, we're gonna send something from a variable. And this is very interesting because this is being cached, and I'm gonna explain why in a second. We're gonna say 200, otherwise we're gonna say 503. And we have some startup. So unless our script has reached this part where it's a self-calling function, then we're gonna say 200, otherwise we can stay starting. But again, the startup probe is not that common. You can actually skip it if you like. We also have some graceful shutdown. So as soon as we get this signal termination event, we can start gracefully shutting down the application, and we're going to set this variable again to ready false. Now, what is this variable? Readiness state, all right? We saw this in this readiness, ready Z endpoint. And readiness is basically a cached variable. So you're going to see that what we're doing to compute readiness for the readiness probe is we're going to do this very basic command or select one into the database just to see if our Postgres database can answer anything, right? We're not even interested in getting any value from that data from there. If not, within 500 milliseconds, then we're gonna return one of these values, either check or we're gonna return error. And if we do, then we're ready, okay? And we're gonna do this every 2 seconds. So the reason is, if we scroll down here, I'm gonna explain why. So imagine everything's fine. So your load balancer is pinging your ready Z endpoint once every second, right? Then your Kubernetes cluster orchestrator is also pinging it every second. Let's say you have a service mesh, so Istio is pinging it every second. And let's say you have some kind of a monitoring or observability tool also pinging it every second. So literally 4 different pings. And let's say you don't have one pod, but you have 100 of pods, okay? Literally 400 requests to your database every second. This is too much, and we want to avoid this. Instead, what we're going to do is literally save this or cache this in a local variable. And we're going to do this interval or compute readiness within a 2-second interval and simply save it in a variable. And instead of reaching out to the database every time, we're simply going to return the value from the variable. This is so much easier and reduces the stress on your database. Now, can you use other frameworks? Yes. If you're using Node.js, you can use this Terminus, pretty good library, automatically creates endpoints for you and much more actually, not just that. So you can see all the options that you can get here. If you're using Spring Boot, there's Actuator, if I'm not mistaken. And if you're using ASP.NET Core with C#, it actually comes pretty much with the health C and all the different health check endpoints almost by default. So this is pretty much it, guys. I hope you learned something new. Don't forget to subscribe, as I said earlier, and I'm going to see you in the next one. Good luck to you.